Well, welcome to my channel. I realized that I had never given an overview of a solar system. So I'm going to try and cover the two basic types, a grid-tied system or solar farm, uh, and a off-grid type system. So let's start at the beginning. Whoops, where is my, there it is. We got our sun energy that passes through the atmosphere, which has weather in it. And we have a group of solar panels or modules or arrays, whatever you want to call it. That's the main input to creating electricity from the sun. Now we have a side effect caused by the temperature, and it's basically caused by the sun as well, that affects the solar panel performance. In a grid-tied system, we're going to go down this path, and these are basically DC voltages and currents. We're going to have a charge controller, which is usually a max power point tracking charge controller, because we want to squeeze as much energy out of the sun that we can. We have an optional battery. They don't always give you a battery with a grid-tied system, so that if the grid goes down, you can keep running your stuff. And it goes into a DC to AC converter, and they call it a converter instead of an inverter because it needs a sync signal from the grid so that the AC here is synchronized with the AC on the grid. I'm going to call that a timing reference. From this point out, we have AC power, either probably 240 volts, that is pumped back into the grid. This is a energy exchange program. Whatever energy you produce goes into the grid, and when the sun's not shining, the grid supplies you with AC power for your lights and appliances and other loads. Some people call this banking your battery on, using this as a battery on the bridge. It's not a battery. If the grid goes down, there's nothing you could do about running your stuff off that. All right, let's go to the off-grid system. We have the same solar panel array. And if you really want to run a whole house, you're going to need a lot of solar panels. 1 or 2 quantity of a couple hundred watts, just is not going to do you much good. Anyway, we go from sun, weather layer, to solar panel array. And we could go into either a PWM charge controller, which is a pulse width modulated charge controller, or a maximum power point tracking charge controller. Of the two, the MPPT is a better choice unless you're in a heavily shaded situation. We go into an energy storage, a battery of some sort, either lithium or lead acid. Are the two main categories, and then there's subcategories under that. But a battery for this type of thing is a chemical energy storage system. When you put power in, it causes a chemical reaction and charges to accumulate on plates inside the battery. And to pull power back out, you have to reverse that chemical reaction to pull power or energy back out of the battery. Then we go to a DC to AC inverter, so we can power our AC loads and lights and appliances. Now, if you have an RV, you might want to tap off the battery and use it for DC appliances, lights and refrigerators and things, small refrigerators and things like that. Solar power stations, which I have one, a Blue Eddy AC50S, basically consists of the charge controller, the energy storage, battery, and a DC to AC inverter. All right. Some people include the solar panel array and then call it a solar generator. Without the array, it's just a power station that covers these three components. Now, I'm not going to get into it today, but AC loads, you can't multiply the current times the voltage to get the watts used. AC loads will often have something called a power factor. That is the phase difference between the voltage and current, and to get the real power into a device, you need to know the power factor. Inductive loads has a power factor, and a non-inductive load would be my TV set. It's rated at 45 watts VA, but it actually consumes only about 33 watts in real power. Now this weather layer here affects everything, and this weather layer could be even on a clear day. The energy up here in space, outer space, is about 1368 watts per meter squared. And by the time it gets down to Earth, depending on where you live, it's somewhere around 1,000 watts per meter squared, unless you have water vapor in the air, dust, dirt, clouds, rain, snow. That weather layer is crippling. And if you have a storm, that's a lot of weather, that's a lot of loss of solar power. Well, that basically covers the overview. These are all DC paths in the blue here. When I go to AC, I turn to red. Okay. The big difference between this converter and that converter, inverter, this needs a timing reference from the grid to sync up. Otherwise, you'll blow up the grid equipment or your own equipment, most likely your own equipment. All right. That's a simple overview. Try to make it short and sweet. Have a great day.